Section 2.5 is an introduction to relations and functions. So in order to talk about functions, think about when something works. When something functions, it works, right? What do you need to function? You have inputs and outputs, right? You breathe in oxygen, you breathe out carbon dioxide. A relation is any set of ordered pairs. A function, in the mathematical sense, is a relation for which each distinct value of the first component of the ordered pair, there is exactly one value of the second component, i.e. each x has only one y value. The best way I can think to talk about this is a vending machine. So let's say you have a vending machine. Vending machines are great. They're full of snacks, right? What happens when you use a vending machine? You push a button and you get chips, or you get a Snickers, or you get, why is there an apple in here? Who knows? A7 gives you an apple. So each input has an output. We could kind of think of this as x and y's, right? You substitute x into a function, you get out a y. So this vending machine functions. This vending machine works because each x has exactly one y value. What happens then if I have D7 going to chips and Snickers? Now, I always have one student who says, oh, you get both. No, vending machines don't want to give you everything. If I push D7, does the vending machine give me chips or does it give me Snickers? Nope, the vending machine breaks down. This is because each x does not have exactly one y value. This x has two y values, being chips and Snickers. So this vending machine won't work. Let's look at one more example. This is the only other type of function we're going to look at. What if I have D7 and E6 both going to chips? Now, don't automatically say, oh no, this is not a function. Because it is, right? If I'm coming across this vending machine and I push D7, I'm going to get chips. And I push E6, I'm going to get chips. And I push A7, I'm going to get an apple. This vending machine still works. So this is indeed a function. So relations are defined as ordered pairs, a table, a graph, an equation, right? These are different ways we can define relations. The domain of a relation is the set of all possible values of x, and our range, this is going to be a really important concept, domain and range, going forward through this class, and our range is all possible values of y. So we've got our domain and our range. So when it comes to our vending machine, right, we had, what did we have? We had D6 and E7 and A6, and we had chips and an apple and a Snickers. I know I got the order wrong. But the buttons, all of the buttons, those would be our domain, right? That's our input. And all of the snacks, right? That would be our range, our outputs. That's one way to think about that. So let's state the domain and range of these three relations and then determine if they are indeed a function. So my domain in this case, I'm just going to represent that with a D, an R with a range. We know my handwriting is not the best, so let's write as little as possible. My domain is 1, 4, negative 1. I'll write that with curly brackets because it's a set. And my range is 2, 5, negative 2. How am I supposed to tell if this is a function? Well, I like to set up a map of my x's to my y's. 1 goes to 2, 4 goes to 5, negative 1 goes to negative 2. This vending machine works. This is a function, right? I push each of these x values. I know exactly what y value I'm getting out. Let's look at G. My domain in this case is -3, -2, 1, sorry, -1, 0. And my range is 5. Oh, I've already got a 5. I don't need to count that twice. 4 and 1. Let's go ahead and draw a map. It's a little odd that my domain is larger than my range. Okay, so let's look at that. I've got my x values of -3, -2, -1, and 0, and my range. I have that -3 goes to 5, -2 goes to 5, -1 goes to 4, and 0 goes to 1. Does this vending machine work? Yes, right? I just have two buttons trying to give us chips. So this vending machine does work. It does function. For 3, let's take a look at the domain. So my domain in this case is -1, -2. I've already got -2, so I don't count it twice. My range is 0 to 1. Let's draw our nice little map. I have -1 goes to 0, -2 goes to 2, and -2 goes to 1. Does this vending machine work? No, this is not a function. And this vending machine doesn't work because if I push -2, what snack am I getting out? I have no idea. I could get an apple. That's not a fun vending machine snack. I also mentioned that we can define relations with a graph. If I'm given a graph, I can use the vertical line test. If a vertical line intersects the graph of a relation at no more than one point, right? So each vertical, which is the x values, right, intersects my graph, which is the output, the y values, at no more than one point, it's a function. So this example, this linear equation passes the vertical line test. This is a parabola. We're going to come across those later. It passes the vertical line test. It's a function. This circle, no. For this one x value, I've got two y values. Here, I have when x is 2, y is 4, and -4. Not a function. Fails the vertical line test.